Welcome to another video on GitLab pipelines. Okay, so last time we saw essential keywords used to create a GitLab CI pipeline. Okay, so we saw the basic keywords like image, like stage, and so on. So if you have not watched the video, kindly go back to this page and you will see our first video detailing how to create a functional pipeline. So today we are going to be seeing the same, almost a similar topic, but we are going to be using advanced keywords that will permit you to script a GitLab CI pipeline like a professional. Okay, so I will need your attention in this. Okay, so advanced keywords that we are going to be using today. So the first one we are going to talk about artifacts. The artifacts in GitLab CI. So by definition, the artifacts save files from a job to be used or downloaded later. So you have a job that is going to need some files later. You have to use artifacts to keep those files so that a subsequent job would just have them. Okay. Next, we're going to talk about rules. So by definition, rules are list of conditions to evaluate and determine whether or not a job is created. Okay, and we are going to talk about the keyword allow failure. Allow failure, that allows a job to fail. A failed job does not cause the pipeline to fail. Okay, with allow failure, we permit that a job can fail or should fail, but it should not break the pipeline. Okay, we are going to see that. Then we are going to see include. So include by definition, it's an importation. So we import configuration from other YAML files. And the last one that we are going to see today is trigger. So trigger defines a downstream pipeline trigger. So you just define a pipeline that is going to be triggered at a certain point. So a job in your pipeline will trigger another pipeline or another job. Okay, so let's go straight to the hands-on. Okay, guys, so this is where we stopped the last time, and like I said, if you haven't watched our first video, so it's going to be linked in the description here so that you can get the basis of how to create a functioning pipeline, and from there you can continue here. So let's go in and demonstrate how to use the first keyword, which is artifacts. So using the artifacts, we are going to demonstrate how they work. Okay, how to implement it, how to script it in your job, and then how to see it in action. Okay, how to see it in action. Okay, so let's go to the YAML. Okay, so here is the YAML that has created this pipeline. Okay, so this pipeline was created from this YAML, from the GitLab YAML. Now we are going to do some modifications to demonstrate the use of artifacts. Now from here I can see that the link job always fails, so I'm going to remove this link job because for ease of use, for ease of readability, just to avoid the failure. So I will just comment the linked test job. Okay, so the link test job has been commented, and then what we are going to do, I will just invert the test job and the build job. So I want the test job to execute, to run first. I want, when I commit my code, the pipeline should run test on the code, and then before another job builds and creates a package. Okay, so I will just take this section and then drop it before this. So the unit test job comes before the build job. That is how we want it now. So we just have to do the test, then build the code, like creating a package, and then use the package or demonstrate the use of the package in the deploy job. Because you see, the deploy job does not have any awareness, does not know what the package is, but the build job is supposed to transmit that package to the deploy job, so that the deploy job should be able to deploy it. Okay, so by so doing, we demonstrate the use of artifacts, because artifacts permit us to save certain files, and then that will be used in a subsequent job. Okay, so let me just totally delete, no, let me just keep it. Okay, the link job is just be there. Now we have to equally invert these stages, because the stage actually shows that the build job will run before the test. So we want the test job, so the test stages, to come before the build. Okay, got it. So now that is the new order of execution of the pipeline. So now we need the artifacts from the build job to be transmitted to the deploy job. So how do we do that? We are going to use the artifact keyword. So artifact keyword, so where do we find it? Remember from the last video, I shared with us a documentation from GitLab that will facilitate our use of each keyword depending on our use case. So let's just go to that documentation and coming over here. I just have, if you come to the top, so you can find, this is the link. So if I just come to the top and you scroll, you go to artifacts, you click artifacts, you get sent to the artifact hashtag. You see, now on the artifacts you see the example. So we are just going to take this basic use, so artifact, and then we are going to define the path that we need to use. So I'll just copy this section, and then I would come in the build job. So the job where I want to save some files, that's why I'm going to define the artifact usage. So here I define artifacts and then the path. So the path of the where the file is, or the directory. So we are going to save a directory, which is the in Java is the target directory, where all the classes and the packages are stored. Okay, so this is the path that we are going to save, so that the deploy job would be able to have access. So you can see, so now since I have already removed the linked test job, I can actually remove this needs. It's going to grab the artifacts from the previous job. So now we have already saved some artifacts here. If we did not save, it's going to find nothing. So but now that we are saving the target, okay, the target file, the target directory, when this deploy job is going to start, it's going to pull artifacts from the previous job, and by so doing it's going to grab our target directory that will already contain the jar file that the deploy job is going to use for deploy. So now to demonstrate that it's going to find that file, how do we do that? So I will just do this. Okay, so I will just paste this here. So let me remove this. So now deploying application. So we have our first command in the script section, which is deploying application, and then we are going to say using artifacts for deployment, and then we are going to show the artifacts actually, okay, which is going to be, we are going to do an ls, we are going to list a jar file that is found in the target directory, if there is any, because you see in this stage there is no build that has been done. So at this stage is supposed to have no jar file, but because we are using artifacts from a previous job, it is going to have one. So this is the demonstration of how to use artifacts. So let's go. Save that. Now I will just add this to Git, then I use a commit message, which I'll just use artifact. Okay, so I'm gonna push. Now let's check that, because after pushing we know automatically GitLab is going to execute or run the pipeline. So let's go and verify. So let's click on pipelines, and voila, our pipeline is running. So I will just click on this. So it's running. Let's give it some time. Okay, so here we have the test job that has already been successful, the build job, and then we have the deploy job which is already successful. So let's first of all verify in the build job if it successfully uploaded the artifacts. Okay, so now when I open the build job, what you're going to notice is this option which declares the job artifacts. You see, so meaning they are some artifacts here we can actually keep, we can download, we can browse. Okay, so and in the job logs you can see that it's under at this line 1328, you see uploading artifacts, and in that is the target directory, and it says found 30 matching artifact files and directories. So it's uploading the artifact as archive. Okay, so now meaning the artifacts were successfully uploaded. So now let's go to the deploy job and see if it was able to use these artifacts. So this is the deploy job. You see, now the deploy job was able to use the artifacts because it says here, first thing first, you see that when the deploy job starts, it says downloading artifacts for build job. You see, it is downloading the artifacts from the build job. Remember, our pipeline does the unit test, then the build job, and then after that deploy. So the deploy job is getting artifacts from the build job, and then you see it does using artifacts for deployment in target slash, you see, that is the demo -0.0.1 snapshot.jar. means it's able to find the file. Meanwhile, it was not locally available, but it grabbed these files from a previous job. That is the use of artifacts. So perfect. So we are going to demonstrate our next keyword. See, the next keyword is rules. So rules are list of conditions to evaluate and determine whether or not a job is created. Okay, so let's just go into the GitLab's documentation and see what it has to say about rules. So just like I said, it's easy, guys. Using this documentation makes life easy. So you just need to know the essentials and these keywords, and then you can always refer to this and see the documentation that is very detailed, and then inspire yourself to use this and create your projects. So we are looking for rows, so it is alphabetically organized. So let's say this is rows, and I click on rows. You see there's a whole lot of rows that we can use here. Okay, now I will just pick any row here to demonstrate how rows work. Okay, so here we have rows. So it reads rows, use rows to include or exclude jobs in pipeline. So if you have certain jobs that needs to be included in your pipeline based on certain conditions, okay, you use rows. Okay, so if for certain branches you want certain jobs to run, maybe you were running some code quality jobs that you want them to execute just on your develop or your main branch, you can use rows to add those jobs dynamically. Okay, so when it's your develop branch, this job is going to automatically be added, but if it's another branch, it will not even feature on the pipeline. Okay, that's one way you can use. And you can use changes. Okay, you can use changes. You can declare if there is a change to a certain file path. Okay, so you declare a file path and say if there is a change in this file path, then run this job. Okay, so there are many different options that you can use to declare rows. So we are going to demonstrate this with if. Okay, let's use the if. So now I will just grab anyone. So let me say I'll take this. So we are going to evaluate using a branch. Okay, so let's demonstrate this with a new job. So I will just create a new job, or let me just rename this link job. Okay, so we are going to demonstrate using rows here. Okay, so I would just edit the link job for it to be a job that I want to always run when we are in the develop branch. Okay, so if it is the develop branch, then this job should run, and if it's not, then this job would not even figure. Okay, so for us to do this, I will just say rename this job, but let me not rename the job. I will just keep it the way it is, but I will just add a row. Okay, so for the role, whatever you want, you can just add the role keyword. See, rows, then and then I paste what I copied. Okay, so I can actually say if the CI commit branch, the CI commit branch is, I will just say equal. I will not use a regular expression, so I will just say if it's equals to, let's say develop. I know that I don't have any develop branches. Okay, so meaning, and then I'm working on, if I look here and I say what is the branch that I'm working on, I will say git branch. Okay, you see it's a master branch that I'm working on. So I know that I'm working on the master branch, so this job should only run when it's on a develop branch. So what would happen? So knowing that we are on the master branch, we know that the lint test job, it's not supposed to run based on these rules. Okay, so let's test that and see it in action. Okay, commit message. Let's use let's say demo rules. Now we just push. So I've pushed and the pipeline is supposed to automatically start running. So what we are supposed to pay attention is that we are not going to see any lint job in the pipeline, and we know why, because we have added the rule. If it is the master branch, then we are going to see if it's the master branch, then we are not going to see the lint job, but if it's the develop, we can see it. So let's go to the pipeline interface. Let me come to pipeline. Okay, we have an error. So what error can that be? This is good. So let's see what error can that be. So it shows here. So we have a rule that is having an invalid expression. Okay, I think I know the problem. So I think here it's supposed to be a string in double quotes. Okay, so now let's save. Add that, commit the same commit message, just push. Okay, so let's go back and check pipelines. Okay, see, it's fixed. So you just need to put the comparison. So for your if, it's supposed to be in double quotes if you are using equals to, but if you're using a regular expression, it's not necessarily supposed to be in a double quote. Okay, so I'll just click open. So what do you notice? There is no lint job. So the lint job does not appear. Why? Because based on our rule says that the lint job is supposed to run just in the develop branch, but now we are in the master branch. You see, this is the master branch, meaning we don't have to see the lint job. But if we create a develop branch and run the job in the develop branch, then we are going to find the lint job up here. Okay, so let's just create a develop branch and then see in action how it happens. But we know that the lint job is going to fail. Okay, the lint job will normally fail, but we just have to see it being created in the pipeline. Okay, so here I'll just create a branch from this. So git checkout this branch develop. Okay, so I'll create a branch from this one which is called develop. So you see, that's all I gotta do, and then I will just do git push origin develop. Okay, so it's been pushed to develop. So if I go over here to pipelines, you see, good. So we are in the develop. You see, now you can find the lint job. Okay, this is a lint job appearing. Why? Because it's in the develop branch. So you see, now this is how we use rules to add certain jobs, to evaluate whether certain jobs should be added or removed from a pipeline based on certain conditions. Okay, so let's go to the next keyword. So what next? We are going to talk about allow failure. We're going to demonstrate how the allow failure works. Allow failure, it means in simple word, it means we allow a certain job the right to fail. Okay, we give it the permission to fail, and then when it fails, it would not break the pipeline, because here So now let's look at this. You see, this lint job has just failed, and because it failed, you see the whole pipeline has broken. So it's broken because the lint test job has failed. You see the status of the pipeline is failed. Now what can we do? Now let's demonstrate the use of allow failure, because if we think that this job is not too relevant, or for some reason this build job and the deploy job must run despite the status of the lint job, so we can allow the lint job to fail. Okay, so let's demonstrate that. So I would still come to the documentation and I'll go right up to the top. So like I said, it's organized in alphabetical order. So if I should just come here, you see this is allow failure, and then I will just get an example. You see it's just a boolean, so allow failure true or false. Okay, so by default is false, so let's pass this to true. So it's simple, guys. So if I just come to the lint test job and I will just add a new keyword, Control V, so I just paste this. So we are giving the permission for the pipeline to, even if this job fails, the pipeline should still go ahead and run, and it should not consider that the whole pipeline has failed because of this job that failed. Okay, so let's see that in action. Control save. Now since we are just going to do this in the develop branch, because that is where the lint test can run. So I will just do git add. Now I will just pass a commit message. Now I will just write demo allow failure. Now let's push and see that in action. It's pushed. Now get here, I will click on pipeline. Okay, so we have a new pipeline that is running. So let's click on this and see how it's going to go this time around. So we know that this lint test job is going to fail in a moment, so we expect to still find our build job going ahead. Okay, so you see at this moment it's not yet cancelled. It's not actually showing a failed status, and it's not actually showing a pass or a success. It's showing a warning. So if you hover over it, you see it's showing that it's failed though, but it's allowed to fail. Can you see that? So allowed to fail, meaning it is permitted to fail for the other jobs to execute. You see, in the previous case, the build job did not just run at all, nor the deploy. But now that we allow the lint test job to fail, other jobs can run. Okay, so that is it for the build. So you see, so because we have allowed the lint test job to fail, it has permitted the build job to run and the deploy job to still run. You see, all of these jobs have run successfully, but in a previous pipeline it could not run because we did not allow this to fail. So it was showing a red cross here showing that the job failed, but here it's failed but it's in a warning. Okay, so you see the overall status of the pipeline is warning. It would just draw your attention to know that there is a warning here, but we still allow the pipeline to go through. Okay, so that is how allow failure works. Now let's go to the next keyword. So here we are going to talk about include. The next keyword is the include. Okay, include allows us to import configuration from other YAML files. Okay, so it's simple. So if you are working with microservices, or you are working with in a modular repository, so you are working with a monorepo but with different services that are separated with in different folders. So you can decide to create a YAML file for each microservice in each directory that contains your microservice. Okay, so by separating this, you can have different YAML file, and then you now include this YAML file in your global YAML file. So let's see what I mean by that. So let's say I want to take the lint test job and the deploy job into a separate file. Okay, so I will just create a new folder. So I'll create a new folder that is called payment. So it's just supposed to represent the payment service. So we create a folder called payment. Okay, just to mimic a payment microservice. Now inside the payment microservice, I'm going to create a file. Okay, I'll create a .gitlab . So you can name it whatever you want. So I will just say .gitlab payment .yml. So I'll call it .gitlab-payment.yml. Okay, so you can still call it .gitlab-ci.yml, whatever you want. So I just want it to reflect the microservice. Okay, so I will just save that. So this opens the file. So in that, I will just grab a portion of this existing GitLab file. So I'll grab this part of the GitLab configuration file. I will just cut this, and then I will go into the GitLab payment YAML file and I will paste this. Okay, so these are certain jobs. So we are trying to mimic having a different GitLab configuration file in a different directory, and then now we are going to include this in the overall, so that in the overall we are going to have a global GitLab. So in the final result, we are going to still have our full GitLab pipeline that is almost looking the same, but in the back end we have different configuration files that define how the GitLab the pipeline looks like. Okay, so I will just save this, then now I have to just import. Okay, so I have to include this, because if I just execute now, you will see that it will just have two jobs. But now I want to include the configuration of another GitLab configuration file, which is this. Okay, so now let's go to the GitLab documentation, and you see how do we use include. You see this is include. You just have to scroll to the top and then you get to include. So now we are including. So you see include, there are many options. You can include a component, you can include a local file, you can include from a project, so you have another project or a repository. You can include a GitLab configuration file that is already found in another project. You can actually call it up in your main GitLab file. Okay, so but in this case we are going to use a local. Okay, so for a local one, you can either use template / in this way, okay, or you can use it straight like this. So I'm going to use this, Ctrl+C. Now I will just come over here, whatever, it doesn't matter where you define that. So it's a keyword on its own, it's not in a job, it's on its own. So you come here, you define that, and then now you just have to declare the path, okay, the path which leads to the file. So here it's payment, right? Then we have .gitlab, so the file is called gitlab payment.yml. okay, so the name has to be the same, you see. So it's the local file that is found in the payment, and then the file is called .gitlab-payment.yml. okay, so that is all we need to do. So what GitLab will do is going to grab whatever the jobs that are defined here, and it's going to respect the stages that we have defined, and it's going to create almost the same thing that we had, but in the back end, you know, in the file definition, in the configuration is different, but at the final result is almost going to be the same thing. Okay, so let's see that. Control save. Commit. So here we have a demo of include pipeline. Yeah, so include pipeline. Now we do a git push, so we push this to develop. Now develop, and I'll go to pipelines. Do we have a pipeline? Yes. So you see, this is the commit demo include pipeline. You see, so we have almost the same pipeline. You see, look. So when you are seeing this from the interface, you will not know what gymnastics the developer, the DevOps engineer has done behind for this to happen. But you see, so we have it all simple here, but behind was a group, was a group of different GitLab configuration files that were brought together to produce this full pipeline. Okay, so this is what we're talking about when we use include. So this include is very effective when you are working with multiple projects, okay, or you are working with multiple GitLab configuration files. When you're working on microservices, you might decide to have each microservice to possess its own GitLab configuration file. Okay, you might decide to have a GitLab configuration file per microservice, and by so doing, you just at the end you just have to have a global GitLab configuration file which has an importation. So you include all of the GitLab configuration files for your different microservices, and in the end you will have one pipeline that globalizes all of the different jobs that you had defined in your microservices. But don't forget to respect the stages. So the stages have to be defined, and every job in your microservice configuration file should respect a stage that is already defined. Okay, GitLab will just have to group the jobs that belong to a certain stage under that stage, and you will see just like this. Okay, so great. So let's proceed to the last keyword. The last keyword is going to be the trigger. Okay, the trigger. So the trigger defines a downstream pipeline trigger. So here, like the word says, we are going to trigger a pipeline. This time it's a downstream or a child pipeline. You see, so it's a child pipeline, and it's different because this, you see here, you see all of them are in a main pipeline. It's the same pipeline, but with this trigger is going to trigger a child pipeline, which is, you see, the first level we have the main pipeline, then we're going to have a child pipeline. So the first pipeline is going to trigger the child pipeline. Okay, So let's see that in action. Let's demonstrate that. So let's go to the documentation. Always go to the documentation, guys. Always go to the documentation. So go to the documentation, you go right up, and you see you will find it here. You can always filter, or it's just in the alphabetical order. So we know trigger, it starts with T. So this is trigger. When I click on trigger, you see a trigger. Use trigger to declare that a job is a trigger job, okay, which starts a downstream pipeline that is either a multi-project pipeline or a child pipeline. Okay, so for a trigger job, you can define, these are the keywords that you can use under a trigger job. Okay, a trigger job is not actually a job in itself, it triggers another job. The function of that job is just to trigger another job. You see, you cannot find script here. There is no script section, so you cannot pass certain commands. Its function is just to trigger another job, which in turn has script. Okay, so we are going to use trigger include. Okay, trigger include is almost like an include, but you know, the include, the first include that we demonstrated, creates a pipeline which is all at the same level. So it brings in the jobs, but it attaches to the main pipeline. Okay, but with a trigger include, it's going to trigger a pipeline which is available locally, but then it's going to become a child. Okay, a child pipeline. So let's demonstrate that and see how it works. But you see, in the different cases, you can always trigger a pipeline from another project. You can trigger a pipeline from different, there are many options here. Okay, but we are going to use the trigger include. So the documentation is easy to follow and to use in your different use cases. So I will just grab this, Control C. I would come to the, so I will just remove this. So let's comment the include. Okay, we are going to use the trigger include. So for the trigger include, I am going to define a new job. Okay, a new job, you see. So I will let me just paste. You see, this is the definition of a job, just like this other one. You see, this is the definition of a job. This is a trigger child pipeline job. You see, so I can just call it trigger child pipeline. Let's just keep it this way. Okay, this is descriptive, but in your use case, you're going to name it the way you want. You can always name this the way you want. So let's keep it like this: trigger a child pipeline. Now, trigger child pipeline, we just use an include, and remember, we use an include here. So I will just get this path. And then paste the path here. Great, see? So we're going to trigger a child pipeline. Save this. Hit add, commit. So we are having a demo of work, demo trigger job. Git push origin develop. Okay, now let's go to the GitLab interface, and then do we have a job? See, a trigger job. You see, so we have a trigger job. So at this moment, this job, this is a trigger job. It starts by doing, you see, it immediately the function of this job is just to trigger a downstream job. Do you see? This one is a downstream job. It's the child job. You see, it's found as a child to this main pipeline. So this first section is the main pipeline, then the second section is the downstream. The downstream, if you want to see the jobs that are found in your downstream, you can always, you see, you can always drop down, and you see, but this is not like a drop down. You see, you can always drop sidewards. Okay, so when you unroll, you're going to see the different jobs that are in your child pipeline. So these are the two jobs that are in your child pipeline. Great, perfect. You see, so with a trigger, the job itself does not actually run any task. Its only task is to call up another job. So it calls up another pipeline or another job. Okay, so this is going to trigger and a pipeline that we have included. Okay, so that is how it works. So based on using the use case for this is, you can equally have some cleanup jobs that need to be triggered at the end of your pipeline or at one point, or a deploy job that needs to be triggered. You can also trigger some jobs from other projects. Okay, so this is how it works. Now, depending on your use cases, you can choose which keywords to use, which keywords not to use. Okay, so this is how the trigger works. Guys, thank you very much. It was a nice experience sharing knowledge, learning together. Guys, don't forget to like, to share our content, and to comment. We are always ready. I am ready to answer each and every question. Thank you.